Alright, in problem number 5, we've got a square with a side length of 2 and a circle that share the same center. The total area of the two regions that are inside the circle and outside the square is equal to the total of the regions that are outside the circle and inside the square. What is the radius of the circle? And you can express your answer in pi. Alright, well, let's see if we can figure out what they're talking about. Alright, I'm going to switch pen colors here. And it says that the total area of the regions that are inside the circle and outside the square. Alright, so that's this stuff here. Alright, I'm going to try and color it in a little. So it's this area, it's this area. Should have a highlighter, shouldn't I? And this area, and this area. Okay, so those are the regions that are inside the circle but outside the square. And then the other regions that they're talking about are the regions that are outside the circle and inside the square. Alright, so let me switch color here. So outside the circle and inside the square is here. So we're talking here about these regions. Alright, this corner here, and this corner down here. Alright, and then we have this corner down here. Alright, and what they're saying is that these blue regions, we'll call those regions, the total of all the blue regions we'll call Y, and let's call the total of all the green regions X, okay? And they say that those two are equal to each other, right? So the total area inside the circle and outside the square is the same as the total area that's outside the circle and inside the square. Okay, so these blue regions are, the area of the blue regions is the same as the area of the green regions. Okay? Alright, now we know that these two figures share a center, and we also know, very important, is that the side length of the square is 2, right? We don't know what the units, but it's 2 whatever, I don't know if it's 2 feet, 2 inches, 2 centimeters, 2 kilometers, I don't know. We'll say it's 2. Alright, so it's just 2. So what does that mean? The area of the square, that's easy, right? So we can easily find the area of the square. And that's going to be just 2 times 2, which is 4, right? Now the area of the circle is a little trickier. We would like to know the radius, because if we know the radius, let's say that's the radius, then we would know that the area of the circle is just pi r squared, right? But we don't really know the radius. But let's work with what we do know and just write out what we know and then see if we can make something of it, okay? So we know that the area, I'm going to call this, define something a little easier to write. I'm going to call this A sub S, and we'll call this A sub C. Alright, area of the circle, area of the square. So I know that if I were to take the area of this circle, and if I were to subtract off the green areas and add on the blue areas, I would have the square, right? So let's do that. Area of the circle, and if I subtract the green parts, okay, which we called, oops, here we go, which we called, the green parts were x, right? Subtract the green parts, and then we add in the blue parts. That's y. And then we would have the area of the square, right? Okay, so you can see, alright, here's the circle, subtract the green parts, add the blue parts, and we got the square. Alright, but we know that the green parts and the blue parts are equal to each other, right? X and Y are equal to each other. So we know that this is 0, right? X, because we have a minus X and a plus Y, and they're both the same thing. So that's just 0, okay? So what does that mean? If that's 0, then the area of the circle is equal to the area of the square. Hey, now we're getting somewhere. We want to figure out what the radius of the circle is, right? That's what it asks for, is the radius of the circle. So if we know that the area of the circle is pi r squared, and we know that the area of the square is 4, right? Now we can solve for r. So let's divide both sides by pi. Okay, that gives us r squared is equal to 4 over pi. And then we can take the square root of both sides. Okay, so square root of, let me just draw it in here, square root of r squared, that just gives us r. And the square root of 4 over pi, well, 4 is a perfect square, so we'll just write that as 2. And then we have the square root of pi on the bottom. So that means that the radius of the circle has to be 2 over the square root of pi. Alright? There you go.